Okay, right, here we have a BBC micro power supply that a friend of mine has given me to look at. Okay, I think first things first. What a wonderful smell. Okay, and I bought a little rebuild kit off eBay. Let's just check the fuse in there first. I think anything blatantly obvious in here, and then I'm going to plug it in and see what expires. Okay, fuse is okay. On off switch on the end. 5 volt, 12 volt, minus 5 volts. Right, okay. Excellent. Not a clue what the orientation is supposed to be. Right, let's try and get these rubber boots pulled back just a bit so I can get the test lead on. Right, test lead inside. So the boot. Perhaps one of our really cheap and nasty multimeters. How do they work? That's a bit of a bugger. Let's grab ground from there. The assumption that this will be a pass through on one of these. Let's do a quick continuity test actually while we're here. Click that onto what I assume is ground. Yeah. Yeah, okay, so they're the two ground pins. And that can stay on ground. Now, under the assumption that does that link through to that one? Yes, it does. It doesn't do to that one, does it? Well, that's a bit worrying. Because why would the 12 volt there, or the 5 volt I assume, loop to that one, and that one? That would not make any sense whatsoever. Let's just see what we actually have as an output. So if they're looped together, that shouldn't really matter, but I assume, assuming the fuse in there is okay, that we should get interesting. Absolutely nothing out of the power supply. Absolutely zero. I'll help you turn it on, of course. So we are missing whatever is happening on this one. Minus 5. Excellent. Oh, just my crappy multimeters. So +5, +5, +5, -4. Excellent. But yet that's supposed to be -5. There's supposed to be a +12 in here somewhere. But looking at that, I would suggest that we haven't. Let's just make sure that discharges. Okay, let this discharge down. I don't know if I'm getting shocked today. Is anything blatantly obvious shorted out inside? Okay, I've let that discharge for a while. Let's get this board removed from the casing. Let's have a look inside, see if there's anything blatantly obvious. That's an awkward sod. That's the earth bond from the casing. Yes, I'm using the correct tool, of course. We can do the whole stack. Yes, we can. Also design that so that you can't get that out easily. Put the board out easily without removing that first. Okay, right. Another earth strap on this side. Very keen on their earth bonding. Never a bad thing, of course. You can see correct tool as always. Okay. Okay, so I spent a little bit more time using the wrong tool. Took 2 screws out of here and the, well, I assume some modular connector off the end of the body, which I'm not quite sure how that fits into the machine, having not got the machine here with me. But, it's quite impressive, really, in just how. I'm taking it out the wrong way, that won't help. And this will probably be supposed to remove the switch body as well. Push the 2 tabs in on the bottom. Unclip the cable tie that's in the body. This goes to the 2 main connectors. Nope, it popped itself back in, as you expect it would. Push that in there. Clip on the top. Clip on the top. Wow. Push it out. Everything's a bit fighty today. That's it. Right. Switch body is out. Hallelujah. She's out. Oh dear. Oh dear, oh dear. So this Rifa cap has completely exploded on this side, so that's an immediate replacement, which I'm under the impression that we will have. Yes, we do. Okay, where's the other Rifa that they're suggesting we replace? Let me see the one. And that will certainly be the smell, which is lovely. Okay, so let's see if we can get that desoldered out the board. That is pretty disgusting. Can't see why that would stop the 12 volt. Let's have a look at these. Okay, so all those reds are into a common body, so all the red ones are the same voltage, which is 5 volts, which corresponds to what we saw. The purple runs on this end here with the blue, which I would assume is supposed to be negative 12, but there's supposed to be a negative 5 rail as well. Not that I have seen, or I assume it must be coming from, that's going to be, perhaps it will be the bit of yellow. The yellow here, looking at this, plus 5, ground, negative 12, and it was the only negative voltage I can actually see on the meter. And I assume this is going to be our negative 5, which I never tested because it hasn't got any fly leads. I wasn't sure that was connected in the system or not from what I've seen. But anyway, let's get this antique removed out of this board. Try the old solder remover first, give it half a chance. Let me see how sad solder remover is when it does that. Okay, that's completely separated. That's excellent. Oh, a lovely smell. Okay, that's that leg, or that's part of the component out. This one here is still holding on for dear life. Okay. Right, and as you can see, that is absolutely exploded. You know, I had it powered up just then, and it It partially works, I suppose. Right, let's restore that. 100 nanofarad, 0.01 mics here, okay. 275 volts for the new one rather than 250 on the original. PMA 271. Okay. I struggle to get that through the hole. And I'm using leaded solder rather than lead free just because I prefer it. As you can see, my delicate flush cuts, as they are at work, are very effective. Not going to cause any issues there. Okay, so try to get rid of some of this mess. Replace that one. What else do we have here? 220 mics, 200 mics, 1000, 1000, 2000. Possibly this one. And the other Rifa doesn't appear to be here. We have another cap down in there. I don't anticipate that to be a fail. That should probably be a resistor across there. Okay, right. Let's power it back up. Let's see if we have the same issue. Yes, I appreciate we haven't got any earth bonding. Still use the switch as termination. Let's see what's going on. And yes, I know I haven't got any load on the supply. It shouldn't make too much difference to this. Yes, it is a switch mode, but I'm sure it will survive. Right, this thing's expired. .5 volts on that rail. Check with this one. -4. Okay, in which case then is this one here. There we go, there's the 12. Okay, so the yellow is the 12, not the minus. Right, okay. That -5 is what's worrying me. Also, need to put some load on it with. See, that cap there is domed. So I think I need to get another kit of resistors. I mean, nothing appears to have leaked or caused any issues. Okay, right. Turn it off, let that discharge. Why does that go up that I do? No, it's my Chinese multimeters. Check the 5 volt rail. Oh, there's definitely some capacitance still working there quite well. And check the 12 volt side. Slowly dropping. Okay, I'll check the schematic and I'll see where the -5 is supposed to get the rest of its voltage from. This is just because it's not loaded. Okay, so after a little bit of research on that, it appears that it comes out of a regulator here, straight out of the transformer. So I'm under the assumption that through a couple of the inductors here, either of these two capacitors are causing an issue. But the kit I have, the other Rifa replaces this one here and this one here. So I'll go ahead and replace them anyway. They might not be at fault, but we'll get them out of the board and we'll just eliminate that anyway. So we'll just tin these leads where this capacitor is now. Trusty old solder socket. Quite impressive. See if I can get this capacitor to come out. .22 mics. Well, that is the wrong size anyway. 100 nanofarads. 275 volts. Similar footprint. Okay. No, there are many holes. Right place. Place that. Okay, and what is this? Capacitor sat in here. Which is T9. No, you're betting, man. We'll go that way. I'm guessing it's going to be these. Yep. Go for that trace. Okay, thankfully it's referenced with the polarity. Clean up that hole on that side. Okay. Drop that in there. Oh, the trace is lifted. Get that back into place. Just put that back on. There we go. Okay. Make sure that's locked in place. Bit of solder there to hold it. Perfect. Perfect. As per the kit, that is the 3 components. But I'm not happy with this capacitor here, so I'll see if I have some parts in stock. Okay, I've had a quick look through. Yes, I have pretty much most of the bits that I need to replace. All these older caps. Could test them, but I've already got them here, so don't damage the trace, don't do it. Okay. That was 100 mics, 100 mics 250, 100 mics 250. What brand is this? Famous Chinese one. Be absolutely fine. Okay. Let's get all that cleaned up. Mics, 100 mics. Both have denotions on the board, which is excellent. Positive, negative, negative. Check that. Positive, yeah. Positive, yeah. Okay, no, happy. Otherwise, that would definitely go back. Okay, soldered fully into place. No, we've got left. That one and that one, and there's 4. Okay. Missed. That is the only 220 on the board. The rest are 1000 mics. Ew. No, definitely not in good shape. Definitely worth having a look at that one. These two. Okay. Last one. With the bigger caps. A little bit of resistance there. There we go. Right. Okay. Put that one back here so I don't forget which one it's supposed to be. Because now that would be a disaster. Okay, that's all in. Okay, right. Let's do these two smaller ones. Okay. And then this one on the side. Okay, hopefully I don't need that again. That one. Stay. one in here. Third and last, which actually you can see has been leaking onto the board. So that one of course been useful to any extreme. So now we're here. So a little bit of isopropyl alcohol. Get all the best we can off the board. We've certainly got a bit of debris off, not a huge amount. Certainly do a better job than nothing. Right into there. Hold those three in place. Okay. Get them soldered in fully. I actually buy the lead-free solder from Amazon. Unless it's for medical usage. Yes, the irony is lead and medical. Yes, you can. You can still use it in certain products. When I used to have a dyno and used to do a lot of work there, doing a lot of electronics, they used to use lead instead of the lead free, just because it just flows so much nicer. And it has so much temperature into everything. Okay, right, that is essentially every capacitor on that board. I think a little tidy up, and then we'll just have to make sure that that will have half a chance of working, I think. Okay, just had a quick mint up. Okay, so unplugged. Neutral. Live. Off. Bit of ground and contact. 5 volt. That's better. Doesn't seem enough, but still is better. Again, could be the multimeter, but certainly an improvement. Much better than it was. Alright, get this reassembled and give it to its owner and see what happens, I think. See how it goes.